Alrighty, so in this video we're going to look at distance and displacement and the differences between the two. But we're essentially going to start off by picking up with where we left off my previous video on scalars and vectors generally. So if you're wondering what these random things in brackets are, it might be worth checking out that video because that's where those come from. So starting off with, we're going to ask ourselves a few questions. So it might be good for you to grab a rough piece of paper in order to do this. So 3 questions for you, and you probably want to pause the video while you have a go at them. How would you describe a scalar? How would you describe a vector? And final question, what would the SI, the System International Unit, what SI unit would distance displacement be measured in if they are lengths? So pause the video now, write down what you think the answer is, and then we'll take a look. Okay, so I'm going to assume that you've done that. So let's get started. So first off, how would you describe a scalar? It's a quantity that can be described using one number. So that's in the brackets, that's why the 1 was there, because we can describe it using one number, which is its magnitude. And you see that's why there was an m there. So how would you describe a vector? So it's a quantity that needs at least 2 numbers to describe it. Magnitude, and direction. So you can see that's where we're getting these numbers for letters from in the brackets there. So vectors can have 3 terms to describe them if we're doing like x, y, and z coordinates or something like that, but we can do it with 2 as a minimum. So what SI unit would distance displacement be measured if they are lengths? All lengths, their SI unit is meters, or I guess m for short. Can we measure it in like centimeters, kilometers, all the rest of it? Yes, of course we can. But if we're going to put it into an equation, the standard unit for that is meters. Okay, so that's where we left off last time. So let's pick up with distance first of all. So you see this is in purple, which in this series means that you should be writing it in your set of notes that you're taking. So this will be the next one that we add. So distance, which we give the symbol d, a lowercase d, is the length of the path taken by an object. So in this context, when we're talking about distance, we're talking about objects moving and how far they've traveled. So let's say we have an object that's followed this path. So it starts over here, where you can see where the x is. It's gone 3 meters upwards, 2 meters to the right, and 1 meter downwards. So it has traveled a distance of 3 plus 2 plus 1, giving you 6 meters. So we can see the fact that the direction of the movement was irrelevant means that distance must be a scalar quantity there. So let's actually add that in brackets in there to our notes there. So what that means is it wouldn't have mattered if we'd gone 3 meters right, 2 meters up, and 1 meter left. We'd still have gone a distance of 6 meters. Even if I'd gone 3 to the right, 1 to the left, and then 2 to the left, I've still done a distance of 6 meters, even though I haven't gone anywhere. So distance has limitations. So if I say this object has traveled 6 meters, it doesn't actually tell you where its final location is, only the length of the path taken. So if I start here and I move 6 meters, I could be anywhere inside this circle here. I could move 6 meters here. I could move 3 meters to the right and 3 meters to the left and be back where I started. I could do 3 to the right, 2 down, 1 down. I could be anywhere inside that circle. So that's the limitation by describing just the distance an object has traveled. We don't know where it is. We just know the length of the path it's taken. So displacement is a little bit different. So it's the length and direction between an object's start and its end. And we give it the symbol S, ys, while d has already been taken by distance, so s was the next best thing, I guess. So we use the symbol s for that, which can get confusing because we sometimes use s for speed as well, but s is the symbol for displacement. So if we look at the same example we met before, where we went 3 up, 2 right, and 1 down, displacement would be this distance here and the direction from going from start to finish as well. So because it has both magnitude and direction, that makes it a vector quantity. So when we add this to our notes, which I recommend you do now, let's put that in there as well, indicating that it's a vector quantity. So very commonly what we would do is say how long this distance is, and we'd maybe give an angle to maybe the x direction or something along those lines. That's how often we give that. So if we actually look here, we can actually figure out what its displacement is before we move into the next one. So here, what we're going to do is actually figure out the length and angle that it has passed through. So we're going to be using a few mathematical tools on this. So I'm going to be using Pythagoras, and I'm also going to be using some trigonometry. Now, I've made a video on using trigonometry in physics, which you might want to check out if you're not quite sure what I'm doing here. But essentially what I'm doing is I'm going to work out the length of these two sides, which make a right angle triangle. So you can see that is 2 meters across there. If that's 3 and that's 1, this must be 2 meters in there as well. So we know that S is going to be equal to, it's a right angle triangle, so we're going to do square root of 2 squared plus 2 squared, which is the square root of 8, which will be 2.8, and it's a displacement, so it's measured in meters. Let me just double check that's correct. Yeah, 2.8 meters. Now, we haven't actually given enough here because we've given the magnitude, but displacement is a vector, so it has a direction as well. So what we're going to do is we are going to figure out an angle inside this triangle. So let's call it in there theta. Okay, so theta, with using trigonometry, is going to be the inverse tan of 2 divided by 2, because the side opposite to that angle is 2, and the side adjacent to that angle is 2. So 2 divided by 2, the inverse tan of that, and that's going to be 45 degrees there. So it's 45 degrees to, let's say, to the vertical direction. And you can see that we could also say 45 degrees to the horizontal direction as well, because that would be the same thing. So this is our displacement is 2.8 meters at 45 degrees to the vertical direction. We've got magnitude and direction. So essentially, so displacement also has a limitation. So distance, remember, its limitation is that it doesn't tell you where the object is now located. It gives you a range of locations it could be, but it tells you how far it's moved. But displacement tells you where it's finished, but it doesn't tell you the length of path taken. So for example, in this one, to get from start to end, we could have gone here, then here. We could have gone here, then here. We could have taken some sort of absolutely bonkers path to get there, but all of those have the same overall displacement because they all start and end in the same place. And this has a problem if we want to work out how much work we have to do to travel this distance if we're dealing with friction and air resistance, because for that we would need to know the distance the object has traveled, not just the distance between the start and the end. So displacement also has its limitations in terms of its usefulness, but it can be very useful to us. Okay, so to finish off, what I want to do is just recap the things that we've met so far. So what I want you to do is you're probably going to want to pause the video to have a crack at this. First question is, what are the similarities and differences between distance and displacement? And then I want to know the distance this object here has traveled and also the displacement of the object. Okay, so pause the video and have a crack at these now, and then we'll go through them. All right, so let's see what we've got here. So first of all, let's take a look at similarities. They are both lengths measured in meters. Okay, so I reckon that would be what they have in common. Difference. So our distance is a scalar. A scalar displacement is a vector. And let's actually add in what these are. So length of the path taken, distance, I probably shouldn't use the word, so the length and direction from start to finish. There. So those are our similarities and kind of differences between them. So if we look at this one, what distance has the object traveled? Distance is easy because it's a scalar. We can just add them. So we're going to do 1 plus 3 plus 1 plus 2. 4 gives us 7 meters. If we want to work out displacement, we're going to need to work out some distances from start to finish. So we need to work out that distance and that distance. So this one is easy. That's where it becomes a problem. So that's 2 meters because it's 1 plus 1. This distance here is 3 minus 2 gives us 1 meter. So that means our overall displacement is going to be given by that vector that we can see there. So that's going to be our displacement, and let's call that in there our angle. So the displacement we can work out using Pythagoras is going to be 2 squared plus 1 squared. 2 squared is 4, and 1 squared is, so square root of 5, which is, let's calculate that. Square root of 5 gives us 2.2 meters. Theta is going to be, I'm going to use tan, so the opposite side to that is 1. The adjacent side is 2. So basically inverse tan over half gives us 27 degrees to the horizontal. So that describes our displacement. It's 2.2 meters at 27 degrees above the horizontal, as we can see in our diagram there. And that's how we'd calculate our displacement there. So just to finish off, as I have been in this video series, I just want to show you what my notes would look like on this video. And I'll be making use of these retrieval cues in a subsequent video, which I'm going to make shortly. So the two things we need to know are what distance and displacement are and what the difference is between them. So you can see here, so if I cover up the right hand side, so I'm just going to stick a magazine across the right hand side, so we can see how the cues get used. So distance is the length of the path between the length of a path an object takes, and it's a scalar. So that's what the L, P, and S are. They give us our keywords in there, the length of the path, and it's a scalar. Whereas displacement is the length and direction from start, between start and end, and it's a vector quantity. So we've got our cues to help us retrieve that information in the future, which will be key to building this information into our long-term memories, which is what we're after here, because we use this in physics quite a lot. All right, so that brings us to an end of this particular video.